Okay, my dear students, now we are going to take up module 5. We discuss straight lines. So what is a straight line? Straight line is a one-dimensional object because it needs only one dimension, that is length. You can also define the straight line as the shortest distance between 2 points. So this you can assume it as a straight line, and these are the two ends of the straight line. You take these two ends as 2 points. So if you consider the straight line, you can consider the straight line as in the first quadrant or second quadrant or third or fourth quadrant. But in any quadrant, it can take different positions. So these different positions are categorized into 4 groups as shown. So what is for number 1? Number 1, you can see the straight line parallel to both HP as well as VP. So take the ground or table surface as horizontal plane and this one as vertical plane. Now the straight line is parallel to both. So this is the simplest of all the positions. So we call this as the simple position. What is the next? Straight line parallel to one and inclined to the other. Suppose you take this. Now it is inclined to the horizontal plane and parallel to the vertical plane, or it can be like this. In this case, it is parallel to the horizontal plane and inclined to the vertical plane. So either of these two, they are called straight line parallel to one and inclined to the other. So what is the third? Third one is nothing but inclined to one, parallel to the other, but that inclination is 90 degrees. For example, you see this is the perpendicular. 90 degrees to HP is also called as perpendicular to HP. So straight line parallel to one, perpendicular to the other, that is here in this case it is perpendicular to horizontal plane, parallel to the vertical plane. Or it can be also like this, perpendicular to vertical plane, parallel to the horizontal plane. So this is the third. Fourth is inclined to both. It is inclined to HP as well as inclined to vertical plane. So these are the 4 different categories in which the straight line can lie either in the first quadrant or second or third or fourth. So how to obtain the projections? We will see. Suppose straight line is parallel to both. You can see in this figure, I have explained with respect to the 2 planes. Now let us assume the straight line as in the first quadrant only. So when it is parallel to HP as well as VP, then you get the front view on the vertical plane and top view on the horizontal plane. And when the horizontal plane is rotated, it comes as shown in the other figure. So you have to draw XY line, then draw 2 projectors for the 2 ends of the straight line, and on that you mark whatever may be the height of the straight line above HP, you mark in the front view here and here. Since it is parallel to HP, height of both the points will be same. So you will get the front view A dash B dash and top view AB. Whatever may be the distance from the vertical plane, you get in the top view. That is this distance, this one and this one. And you will get the top view of the straight line AB. One thing you can observe from this, both the projections, front view as well as top view, they are having the true length. That means same length as that of the original object. So when the straight line is parallel to both projections are parallel to xy, that is number one. Another point is both projections are having true lengths. So that is what you should remember when the straight line is in the first quadrant and parallel to both. Now let us take the second case. Straight line parallel to one and inclined to the other. As I told you, this is again two cases. First case, straight line parallel to VP and inclined to the HP. Second case, straight line parallel to HP and inclined to VP. You can see the figure. Here it is parallel to VP, inclined to HP in the figure A. So, inclinations of the straight line, they are given by these symbols, that is theta. Theta is used for the angle with HP and phi is used for the angle making with VP. So these are the symbols, not only in our college or in our university, they are universal symbols. So please remember, theta means the angle making with HP and phi means angle making with VP. Just like A dash represents front view, A represents top view. Now let us look at the figure at A. Here the straight line is parallel to VP, inclined to HP. How do we do this? First you assume the given angle, that is theta, as 0. Then it becomes parallel to both. So assumed position you call it as A B1 and correspondingly you get A dash B1 dash and A B1, they are front view and top view having true lengths. Now you rotate the front view A dash B1 dash to the required angle and again the length remains same. That means A dash B dash will also have the same length, but correspondingly the top view length gets reduced from AB1 to AB. So this is how you must remember, the length of the top view reduces depending upon the angle theta, but the front view length remains same because it is parallel to VP. If you look at this, when it is parallel to HP, the length of the top view remains true length, and whereas the front view length decreases and it depends upon the angle phi. So here also first you assume the given angle phi as 0. That means you convert into simple position and draw the first simple position, top view, front view, and later you have to rotate the top view and then get the corresponding front view. So which one is to be rotated? You have to remember, if it is making an angle with HP, you rotate the front view. If it is making an angle with VP, you rotate the top view. This is one important point you have to remember. Another thing, front view remains true length if it is parallel to VP, and the top view length reduces if it is making an angle theta. From this figure, the top view remains having true length, the front view length reduces. So you have to remember, when will you find true length, when will you find the length less than the true length. Now coming to the other case, straight line parallel to one and perpendicular to the other plane. So here again two different cases, parallel to VP and perpendicular to HP as shown in figure A, parallel to HP perpendicular to VP in the B case. So simply this is just like the previous case, only the angle theta will be 90 degrees. So as in the previous case, first you assume the 90 degrees as 0, it becomes parallel to both, and afterwards because theta is 90, you rotate the front view, it becomes perpendicular to XY. What happens to the top view length? As the angle increases to 90, the length of the top view reduces to 0. So that means both the points will coincide. That means length in the top view becomes 0. So similarly, if you look at this case where it is parallel to HP and perpendicular to VP, again you assume first the phi as 0, and that means it is parallel to both. Then rotate the top view by 90 degrees, the front view length becomes 0. That means A dash B dash coincides. So let us see the conclusions. As I told you, one of the projections will have true length, the other projection will be having 0 length. And coming to up to these three cases, that is parallel to both, inclined to one parallel to the other, and parallel to one and perpendicular to the other, some problems are given for you to practice under three different categories. Now coming to straight lines inclined to both, this is the fourth case. So here both the angles are neither they are zeros nor 90 degrees. So how do we proceed this? Here it is like this. This angle is theta and this angle is phi. So first imagine this straight line as inclined to both like this. So what you do is assume both the angles 0. It becomes parallel to both. So first thing what you have to do is assume the two given angles as 0, and that means you are converting into simple position. For that I have shown the figure, the front view and top view. Next what you do is take only one angle theta. So you rotate the front view as shown at B, and correspondingly you get the top view. So I am calling it the second case as AB2. First one AB1, second AB2. Now third, I am taking only phi angle. So it is parallel to HP, inclined to VP. So here I am taking it as AB3. So top view is having true length, front view is reducing. So I am splitting the given problem into three cases: parallel to both, inclined to one, and parallel to the other. Now how to all the three cases. Now you can see in this figure done on a common XY line. Previously we have seen on different XY lines done separately. All the three cases you can do at one place on a common XY line by naming differently. So same thing, A dash B1 dash, A B1 represent parallel to both. Next, A dash B2 dash and A B2 represents the second case, that is parallel to HP inclined, parallel to VP inclined to HP. Third case is A B3 and A dash B3 dash. So all the three cases shown on a single XY line, because you have to do like this. Then what is the final? Now afterwards, how to join, get the final result? So I will explain. You draw two parallels PQ and RS parallel to XY line, passing through B2 dash, B3. Next what you do is, you take A dash B3 dash as radius, A dash as center, you draw an arc until it cuts the horizontal line PQ at B dash. Similarly, you take A as center, AB2 as radius, you draw an arc until it cuts the line RS at B. Now you join A dash, B dash and AB. They represent the final front view and final top view. The verification whether the procedure you have done is correct or not, you can check up yourself by joining B dash and B. If it should be perpendicular to XY line. If it is perpendicular, your procedure is correct. So this is how you can verify yourself. So the final projections are A dash, B dash and AB. They are inclined at alpha. A dash, B dash is inclined at alpha. AB is inclined at beta. These are the angles made by the projections. Please remember, angles made by the straight line theta and phi. Angles made by the projections alpha and beta. These are the two how you represent. Alpha means angle made by the front view, beta means angle made by the top view. So one should remember these notations. So what is the conclusion from this? When a straight line is inclined to both, as you have seen in the figure, none of the projections, that is neither front view nor top view, are having true lengths. That is one thing. Next, both the projections are inclined to XY at alpha and beta. None of them are parallel to XY. So this is very important to remember. Now straight line inclined to both planes when sum of the two angles is 90. This is a special case, that is when theta plus phi is 90. See, that means theta suppose is 30 and phi is 60, sum is 90. So you please check up when you are given a problem with the straight line inclined to both, the angles you check up. So if the sum is 90, okay, the procedure is same, but the final result you get in a particular fashion. So you adopt here in this figure, you can see the same procedure has been adopted, just starting from parallel to both, then taking inclined to one, parallel to the other. So you got three top front views, three top views. So and as usual, here also A dash, B3 dash is rotated by 90 degrees because this length is equal to this length. You can see. Because of these two are same, it becomes perpendicular. A dash, B dash becomes perpendicular and AB also becomes perpendicular. So ultimately A dash, B dash, AB comes on a single projector. Please remember. So if the sum is 90, you get the final projections like this on a single projector. So you may be surprised why the result has come like that. So mathematically you can see on the figure why, because of the distances being same, you get the final results like that. So traces, what is meant by a trace? Trace is nothing but a point of intersection of the straight line with the plane. Suppose you take this straight line, it is inclined. Suppose you extend it downwards, it will meet the horizontal plane. So this is called the horizontal trace. Suppose if it is inclined like this, and if you extend towards vertical plane, it will go and meet the vertical plane. Then you will get the vertical trace. So trace is nothing but the point of intersection of the straight line with the reference planes. So maximum you will have two traces. That is, if it meets the horizontal plane, you get horizontal trace. If it meets the vertical plane, you get a vertical trace. So this is how we will start with the 4 different cases. Before that, how to name these traces. This table shows how to name the horizontal trace. Horizontal trace is nothing but a point on the horizontal plane. So if a point is on the horizontal plane, as we have seen in the module 4, a point on HP will have its front view on XY. that front view we represent by small h. Please remember, it is not by h dash. It should be represented by small h. Small h represents the front view of the horizontal trace. Capital HT represents the top view. So you please remember how we name them, not just as a h or h dash. Okay. So next, coming to vertical trace. Vertical trace is nothing but a point on the vertical plane. Therefore, its top view comes on xy and it's represented by small v, and its front view is represented by vt. So this is somehow you have to remember the naming, as it is different from the previous practice. Okay. So now let us take how many traces you will have for each case. First case is straight line parallel to both. So as you have seen, a dash, b dash, ab, they both are parallel to xy, and when you extend these two projections, they will never meet xy line. Therefore, no traces, since AB is parallel to both. So you please remember, when a straight line is parallel to both, you will have no traces. Second case, when it is inclined to one plane parallel to the other, you know how to get the projections. After getting the projections, now you extend a dash, b dash towards xy. Where it meets the xy line, that is small h, that is the front view of the horizontal trace, and top view must be on the same projector, and you just extend BA, and where these two lines meet you will get HT, that is the top view of the horizontal trace. So you will have only one trace because it is parallel to one and inclined to the other. Similarly, here also you will have only one trace, that is vertical trace, because it is parallel to the other plane. So how to obtain that vertical trace? You first extend this top view to meet the xy line, that is the small v. At small v you erect perpendicular and you extend b dash, a dash, you will get vt. So you will get the front view and the top view of the vertical trace. So please remember, in this case you will have only one trace, either horizontal trace or vertical trace. And if you take the third case, that is straight line parallel to one and perpendicular to the other, here also you will have only one trace, and here in this case it is perpendicular to HP. Therefore, if you extend towards xy, you will get h, and HT will be at the same place as a dash, b dash. So all the three will be at same place. So you will have only horizontal trace in this case. Similarly, here you will have only vertical trace. So here also, in both the cases, you can see there is only one trace. When a straight line is parallel to both, you obtain the projections a dash, b dash, ab. Now how to find the traces? You take up, say, first front view. You extend b dash, a dash towards xy line until it cuts the xy line. Where it cuts, it is represents a h. Then you extend BA towards xy. Where it meets the xy line, you get v. And at h and v, you erect perpendiculars and you extend the front view and top view. So you will get HT and VT. So in this case, please remember, you will have both the traces. Okay. So how many traces will be there when the straight line is parallel to both? None of them. No traces. If it is parallel to one and inclined to the other, only one case, one trace. If it is inclined to both, you will have both the traces. So if you are asked to determine the traces, you have to determine after the projections are over. So now sometimes, here again we have seen the case when the sum of the angles is 90. So here when the sum of the angles is 90, how to determine the traces is this. So this is a side elevation from the side elevation you have to get in the side elevation you extend both sides, they meet XY line here at HT and X1 Y1 line at VT, and you draw horizontals and then you get the actual positions of the traces as shown here. But how to get the side elevation and all we will see in the coming modules. So these are the points. Some direct problem, I am explaining one problem. Here the problem is this: a line PQ of 100 mm long is inclined at 30 degrees to the HP and at 45 degrees to the VP. Its midpoint is in the VP and 20 mm above the HP. Draw the projections. If its end P is in the third quadrant and Q in the first quadrant, find what we have to draw the projections. Okay, so this is a simple case, straight case. This is the PQ 100 mm and this angle is 30 and this angle is 45. Sum is not 90, please remember. But he has described about the midpoint. Let us call this midpoint as M. Okay, so if you look at this, you now forget about the total line, you take the given line as MQ. So he has given you the positions of the M midpoint. You can locate M dash, and as usual you construct as explained earlier for a case parallel to inclined to both. After getting the final projections M dash, Q dash, MQ, you simply extend and mark the double the length. For example, if you extend Q dash, M dash and then mark M dash P dash is equal to M dash Q dash. Similarly, mark MP is equal to MQ, and automatically you can see P is coming above XY, P dash is coming below XY. That means the point P, the end P is in the third quadrant as said in the problem. So please remember, this type of problems you start by taking from the midpoint to the other end as the given straight line first, and then you get the other end by extending. Okay, so these are some of the problems: direct problems, indirect problems. What is meant by indirect problem? Instead of giving the angles, he will say one end is at say 10 mm, other end is at 30 mm. So if they are at different heights, it is making an angle with HP. So similarly, if it is at different distances from VP, that means it is making an angle with the VP. So indirectly, by giving the distances, the angles may be given. So these are some of the problems we can go through. Okay, thank you.